Hi dear students, let's see this question that came in JEE Advanced Paper 1 Physics in the year 2021. The question is from the topic of magnetism plus modern physics. Slight knowledge of modern physics will be required, although not much. Uh, the question is based on numerical type, more precisely integer type, not numerical type actually. So the answer to this question will be an integer, and this was based on the marking scheme of +4 and 0 marks. So let's see what's happening over here. In this question, basically an alpha particle whose mass has been given as 4 mu and a singly charged sulfur ion whose mass is 32 amu. They both are initially at rest. They are accelerated through a potential difference of capital V, and then they perform circular motion in a magnetic field. The magnetic field for both of them is same. The radii of alpha particle and the radii of sulfur is Ra and R alpha and Rs. So we have to find the ratio of R sulfur to R alpha. So very easy question. So we can say that R is nothing but m into V upon Q into B, right? Where m is the mass of the particle, V is the speed of the particle, speed of the circular motion, Q is the charge on the particle, and B is the magnetic field. So this is the radius of the circular motion. Whenever the velocity of a charged particle is perpendicular to the uniform magnetic field, so in that case the particle performs a circular motion. Okay. Now if you find the value of R sulfur, so the mass of the sulfur can be taken as 32 m. Okay. Acha, one more thing before we go ahead with this. This mv is nothing but the magnitude of the linear momentum, which can be written as 2 into mass into kinetic energy. Okay, you remember there is a relation between linear momentum and the kinetic energy. So linear momentum P can be written as 2 into mass into kinetic energy, where P is the linear momentum. Now the kinetic energy of this particle, since it has been accelerated from zero velocity to the and it has been accelerated through a potential difference of V volts starting from rest, so its kinetic energy would have become QV, where Q is the charge and V is the potential difference. So kinetic energy can be written as QV, okay, divided by QB. So this is the general result that we are going to use. Now R of sulfur can be written as 2 into mass of the sulfur, which is 32 m. I am taking 1 amu as m only. So 32 amu I am writing as 32 m. Charge on the sulfur will be Q because it's a singly charged. So I am taking Q as a single charge and V is capital V. Divide by Q into B. R of alpha will be 2 into mass of alpha will be 4m. Alpha particle is doubly ionized. Therefore, we can say that it will be 2Q into capital V divided by 2Q into B. Now, if you take the ratio R of sulfur upon R of alpha, then we can say that QV, QBM, everything will get cancelled. Only numbers will remain. So here it will be 64, and here it will be 4 to the 8 to the 16. Okay, and this 2 will go in the numerator. So this becomes 8 into 2 divided by 4, and hence the answer is 4. So the answer to this question will be 4. Again, this was a super easy question, just formula based mains level question, which most of the students would have done it quite easily. That's it. Thank you.